Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics chapter differentiation. We already studied in 11th standard the basic concepts, uh, standard functions, derivatives of standard functions and rules of differentiation, etc. So we'll just start with the recall of these previous topics. The derivative is one of the fundamental ideas of calculus. It's also about the rate of change of function. The symbol delta will be used to represent the change. For example, delta x represents a small change in the variable x and it is read as change in x or increment in x. Delta y is the corresponding change in y if y is a function of x. For differentiable function, y is equal to f of x is delta x and a small increment in x and the corresponding increment in y is delta y. Then limit delta x tends to 0, delta y upon delta x is equal to dy upon dx is the definition of derivative we already studied. The derivative of f of x with respect to x at x equal to a is given by f dash a is equal to limit h tends to 0 f of a plus h minus f of a upon h. This is called first principle method. The derivative can also be defined for f of x at any point x on the open interval as f dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h. If the function is given as y is equal to f of x, then its derivative is written as dy upon dx is equal to f dash x. So at a point also you can define or you can define at x also. Derivatives of some standard functions, we already studied these tables last year. You can remember this once again. So derivative of constant is 0, derivative of x is 1, derivative of x raised to n is n into x raised to n minus 1, derivative of 1 upon x is minus 1 upon x square, derivative of 1 upon x raised to n is minus n upon x raised to n plus 1, derivative of root x is 1 upon 2 root x, derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is sec square x, derivative of sec x is sec x into tan x, derivative of cosec x is minus cosec x into cot x, derivative of cot x is minus cosec square x, derivative of e raised to x is e raised to x, derivative of a raised to x is a raised to x into log a, derivative of log x is 1 upon x, derivative of log x to the base a is equal to 1 upon x log a. This much we already studied in 11th standard. Now rules of differentiation also we completed. If u and v are differentiable functions of x such that y is equal to u plus v or u minus v, then derivative of y is equal to derivative of the first function plus derivative of second function or derivative of first function minus derivative of second function. Y is equal to u into v. Two functions are given in product form, then it is called product rule. Derivative of y with respect to x is u into derivative of v plus v into derivative of u. Y is equal to u upon v, where v not equal to 0, then dy upon dx is equal to v du upon dx minus u dv upon dx upon v square. This is called quotient rule. Now from this slide onwards we are going to study derivatives of composite functions, derivatives of inverse functions, derivatives of logarithmic functions, derivative of implicit functions, derivatives of parametric functions, higher order derivatives, and some more rules of differentiation of etc. in this chapter. So we'll start with the derivatives of composite functions, that is function of another function. Through example you can understand this. Examples for composite functions are like this. Sine of root x. Normally in trigonometric function we used to write sin x and all, sin x cos x, but in the place of x it is given as root x. One more function is included in the angle. Here it is log of sine of x square plus y, that is in the place of x, it is sine of x square plus y, and in the place of sine x, instead of x here, x square plus y. So this is first function, and sine of this one, this is the second function, and log of this is the third function. Function of function of function. E raised to tan x, in the place of x it is given as tan x. So this way the functions will come, that is called composite function. Now for solving this kind of questions, you have to study this theorem. This theorem is called chain rule. This is very important theorem. It is 3-mark question for board exams and all. If y is equal to f of u is a differentiable function of u, and u is equal to g of x is a differentiable function of x, such that the composite function y is equal to f of g of x is a differentiable function of x, then the chain rule is this one: derivative of y with respect to x, dy upon dx, is equal to dy upon du into du upon dx. So we'll start with the proof. In this statement, it is given as y is equal to f of u, that is a differentiable function of u. Y is a differentiable function of u, and u is a differentiable function of x is given, that is y equal to f of u and u is equal to g of x. So we have to assume u is not a constant function because it is coming with respect to u. We are taking derivative of y. So if it is a constant function, it will become, derivative becomes 0. That is why we have to assume it is not a constant function. Let there be small increment in the value of x, say delta x, and delta u and delta y are the corresponding increments in u and y respectively. Now as delta x, delta u, delta y are small increments in x, u and y respectively, such that delta x not equal to 0, delta u not equal to 0, delta y not equal to 0. Then now we have to start this theorem where we will assume this kind of things. But remember, this is the formula, you have to prove it. So for that we have to take one ratio to start. That's why we are taking delta y upon delta x. As I already told you, the derivative definition is dy upon dx is equal to limit delta x tends to 0, delta y upon delta x. So here we are considering this ratio, then you will take the limit value to both of these sides of this ratio, then you will get the result. For that we have to consider this way. So we are considering the ratio delta y upon delta x, and this can be written as delta y upon delta u into delta u upon delta x. The meaning is same, both the sides are same. So you have to remember this part, then only you will get this. So you remember this, this you will get, sometimes you will get this in your question paper. So you have to just remember this part. You have to reach dy upon dx, derivative of y with respect to x. So for that we have to take the small increments in y with respect to small increments of x as the incrementary ratio. Then you will take the limit value to both sides. So here the same thing we are considering, but instead of writing d, we are taking all the delta values here. Now we will apply limit to both sides. So taking the limit as delta x tends to 0 on both sides, we get limit delta x tends to 0, delta y upon delta x is equal to limit of delta x tends to 0 to both of these functions. Then we will split the limit to both the terms like this. Now here you have to check it. It is delta x tends to 0, delta y upon delta u. But the derivative of this function with respect to u you have to take, but here it is delta x tends to 0. So you have to make it as delta u. That you can do because as delta x tends to 0, we get delta u tends to 0, because since u is a continuous function, there is again if it is tending towards to 0, this must be tending towards to 0, so that you can change that term to delta u tends to 0 in that. Then you will give that equation as 1. Since y is a differentiable function of u that is given in the question, so limit delta u tends to 0, delta y upon delta u exists. That means the first term exists. And u is a differentiable function of x, then the second part is also exists. So if both of these terms are existing, you can write limit delta u tends to 0, delta y upon delta u is equal to dy upon du, and limit delta x tends to 0, delta u upon delta x is equal to du upon dx. So from 2 and 3 you can write as limit delta x tends to 0, delta y upon delta x is equal to dy upon du, and in this place you are writing du upon dx. So RHS is existing and it is finite. So since it is an equation, left hand side must be finite. So you can write this part as dy upon dx. Hence we prove this theorem. Now you can write the chain rule like this also. Y is equal to f of u is a differentiable function of u, and u is equal to g of x is a differentiable function of x, such that the composite function y is equal to f of g of x is defined. Then dy upon dx is equal to f dash of g of x into g dash of x. Composite function it is, that is why we are writing first function and the derivative of the second one. Now, if three functions are given, y is equal to f of v, it's a differentiable function of v, and v is equal to g of u is a differentiable function of u, and u is equal to h of x is a differentiable function of x, then we can use chain rule like this. Dy upon dx is equal to dy upon dv into dv upon du into du upon dx. So you can see this is connected like chain. So that is what is a chain rule. Now, generalization of chain rule is like this. If y is a differentiable function of ui and ui is a differentiable function of ui plus 1 for I equal to 1, 2, 3, etc. n minus 1, and un is a differentiable function of x, then you can write it as dy upon dx is equal to dy upon du1 into du1 upon du2, etc. dun upon dx. Like all are connected like this. Now we have studied this previous year, all the standard formulas. Now here composite functions are given. Only difference is that in the place of x it is f of x. So x raised to n, instead of x raised to n, here it is f of x raised to n. So derivative of x raised to n is n into x raised to n minus 1 into n minus 1. That's it. But here you have to take, since the function is not x, so as usual we will consider this as x. So n into f of x raised to n minus 1, as it is you will write. Only difference, in the place of x you are writing f of x, and you have to take, since it is not x, you have to take the derivative of that also. So in all this formula you already studied, only we are changing, in the place of x we are changing this one. So root of f of x is 1 upon 2 into root f of x into f dash x. 1 upon f of x raised to n is minus n into f dash x upon f of x raised to n plus 1. Sin of f of x is cos of f of x into f dash x. Cos of f of x is minus sin of f of x into f dash x. Tan of f of x is sec square f of x into f dash x. Cot of f of x is minus cosec square f of x into f dash x. Similarly, sec of f of x is sec f of x into tan f of x into f dash x. Cosec f of x is minus cosec f of x into cot f of x into f dash x. A raised to f of x is a raised to f of x into log a into f dash x. E raised to f of x is e raised to f of x into f dash x. Log f of x is 1 upon f of x into f dash x. That you can write like this. Log f of x to the base a can be written as 1 upon f of x into log a into f dash x. So you have to by heart this table, but by understanding the concept. So once you finish that basic standard formulas you already studied, then it is easy. Only we are changing, in the place of x it is f of x.